Okay, naming molecular compounds it's different. Definitely different than naming ionic, for sure. Not that it's any harder, but there's just a little bit more that you have to remember in dealing with molecular compounds. First thing that you need to know is you need to know all the prefixes that we will be using for molecular. So the first one you need to know is mono. Mono refers to one. Di refers to two. Tri refers to three. Tetra is four. And penta is five. Our rules are going to be the same as before. So I'm not going to restate them. I'm not going to rewrite them down. You write the name of the metal, you write the name of the nonmetal, the name of the nonmetal with "ide" at the end, and you have to throw the prefixes on based on what your ionic number was, okay, or your subscript. So let's take the first one. Let's go with hydrogen dioxide. I'm going to work backwards here. I'm going to actually start off by giving you the molecular name, and we're going to actually write down the compound from the name. I think that's always a little easier to do. First thing, you'll notice that the di is referring to two, but there's nothing on hydrogen. On the first term, if there's nothing, it actually means one, and you just don't write mono on the first one. That's like a first little rule. You don't go mono hydrogen dioxide, you would just go hydrogen dioxide. And what that means is HO2. Okay? That's what that means. One hydrogen, two oxides. Let's try dinitrogen pentachloride. Okay, dinitrogen pentachloride. Dinitrogen, now di is 2, so that's going to be N2. And pentachloride, penta is 5, so chlorine with 5 on them. Dinitrogen pentachloride. Let's try arsenic monoxide. Now you see your mono. The mono always goes in the second one. It never goes in the first. Okay, so arsenic by itself, arsenic is AS. Monoxide is O. There, ASO. Arsenic monoxide. Hydrogen dioxide, dinitrogen pentachloride. Now that we've seen the names and written down the compounds, let's do some compounds and write down the names. So let's go to this compound, P2O3. Well, di is the 2, so that's going to be diphosphorus. And 3 is trioxide. Trioxide. Okay, let's go to the next one. S2F4. Well, first thing you'll notice is that people are going to want to try to simplify this to SF2. You don't do that. The nice thing about molecular compounds is whatever you're given as a compound, your name is just read off of this thing. And whatever your name is, your compound is just created off of that name. You don't have to look anything up on your periodic table. And notice I'm not grabbing the periodic table all the time like I was for covalent. So this stuff, you just have to read directly. S2, that's going to be disulfur. And 4 is tetrafluoride. Disulfur tetrafluoride. How about this one? CS3. That's going to be carbon, not monocarbon, but carbon trisulfide. And here's another trick for you. Cl2. I've seen some, this is a diatomic. You have to call something, you have to call a diatomic something. You can't just say it's the diatomic of chlorine, although that would make sense. I've seen some people call it dichloride, or what I think is a little bit more common is just calling it chlorine gas. Okay, two possibilities for your diatomics. So if we had, and the iodine's always a weird one, if we had I2, it would be diiodide. That's weird, hey? Diiodide. Or maybe it's even diodide. Who knows? But it's still strange enough. Diiodide, which is so much easier to say iodine gas. Anyways, there you go. Ran you through naming molecular compounds. Enjoy.